It's bigger, more powerful, but is it better and worth the upgrade? I've had this entry-level desktop CNC from TwoTrees for a while now, and I've been really happy with it. I keep finding new uses for it in my projects, things I never could have done before stepping into the world of CNC. But today, I'm taking it a big step up. I've just got its big brother, the TTC 6050. In this video, I'll put it to the test. I'll start with a quick unboxing and assembly so you can see what this machine is all about. I've added chapters, so if you want to skip ahead to the testing, feel free, but I'll point out a few strengths and weaknesses during assembly that might be worth sticking around for. Right on top of the box is the manual, and a big surprise, a whole set of end mills. I've never seen a machine ship with this many before. Very cool. Next up, a box with tools for assembly, all the screws and fixtures, plus even more end mills. Some cables, a memory card, you also get a C-probe, a spindle light to illuminate your work area, and an infrared safety beam for the front of the machine. Then we get into the bigger parts, the frame components including the Y-axis motor and drive unit, some heavy MDF panels for the bed. Along with those, there are aluminium brackets that hold the panels in place and provide slots for holding fixtures. In the next layer we got cables for the spindle and Z-axis, the side and front panels, and the X-axis motor. The spindle motor itself is a 500 watt unit. There's also safety gear, glasses, ear protection you have to assemble yourself, and fittings for both the spindle and the router. Then comes the external controller. It has a large display, a knob to adjust spindle speed, an emergency stop, and a safety switch for the spindle. You also get a mostly pre-assembled Z-axis unit with a large manual adjustment knob, just like on the other axis. And finally, the gantry. Big, solid, and heavy. Everything is packed incredibly well in this surprisingly small box, and I'll never make it all fit if I have to pack this up again sometime. Oh wait, there's more. Hidden at the bottom is the back panel, a Y-axis support, and even some sample materials in a secret slot. That's the full content of the box. Now let's get it assembled and move on to the testing. The manual is really well done, just like with the other TwoTrees products I have. Clear parts list, step-by-step instructions, and all the screws are neatly labeled, so there's really no way to get this wrong. I'll start with the frame of the base, which also houses the sliders and drive motor for the Y-axis. These parts are heavy and very sturdy. One thing worth noting, the machine has a pretty large footprint. If your workbench is less than 80 centimeters deep, you might struggle to place it securely. The design itself is smart, with cable management to keep things tidy. Next, I secured a knob on the drive shaft of the motor, which lets you manually move the spindle. All axes come with these large knobs, which is a nice touch. Then comes the brace for the drive unit. Once attached, it moves the gantry back and forth along the Y-axis. After that, the elevated sides that hold the clear plastic panels. And here's the transmitter and receiver for the infrared safety beam. This is new. If you reach into the work area while the spindle is turning and break the beam, the machine shuts down instantly. A clever safety feature. Next up are the support brackets for the work area base, followed by the MDF panels. And let me just say, if TwoTrees think I'm going to drive in 32 screws with that little hand tool they included, they're dreaming. I used a drill instead. Just remember to set it to a low torque. Also, there are two types of screws for the middle and the edges. I learned that the hard way and had to redo a few. The gantry comes mostly assembled, though you have to attach the motor for the X-axis. Once that's in place, the gantry mounts onto the base with large solid screws. Then I prepared the cable management on the back of the gantry. All cables come pre-bundled in sheathing and run smoothly inside a cable drag chain. It's a great solution and almost foolproof, so you won't run into issues when moving the machine to its limits. Now for the side panels. With the elevated sides, the sealed floor, and the tucked away gantry attachment, dust simply can't reach the Y-axis mechanics. The same goes for the X-axis parts, hidden in a small slot at the back of the gantry, almost completely sealed. That means you can run jobs all day long without dust grinding into the parts that hate dust. That really helps with longevity. Once the spindle and Z-axis unit are attached, I plug in the wiring and install the spindle motor. The work light attaches to the spindle bracket, and most cables are tucked neatly away. The only weak point I see is the wiring for the infrared beam. It looks a bit exposed compared to everything else. Not a deal breaker, but a little out of place in such a tidy build. Finally, the controller connects with a large plug, and a very clear warning not to attach it upside down. I'll try not to mess that up. And that's it, assembly done. The machine is huge, super heavy, and overall very solid. Everything looks great, aside for that minor infrared cable detail. Now, let's fire it up and do some testing. Before starting any real testing, I'll power up the machine so you can see the controller screen. You can actually run the whole machine from here, just by loading your G-code on a memory card. I prefer connecting it to my computer and using Easel. That way, I can both create designs and run the machine remotely, while seeing a live visual representation of what's happening. Very practical. For my initial test, I'll set up a simple design using the text function in Easel. I attach a 3mm straight cut end mill and clamp down a small piece of MDF. Before engraving, I jog the machine to all its extremes to check the limit switches. This helps you understand the true working area of the base. Seems in this setup, the maximum working area is roughly 57 cm by 48 cm, so not the full 60-50, but I think that's quite normal in the industry. Let me know in the comments if I'm wrong. The initial test went as expected. Everything seems to work just fine out of the box. One thing the machine doesn't come with is a dust collector, so I had to improvise with my shop vacuum. TwoTrees do sell their own solution, but I didn't get one this time. For now, this will do just fine. Now it's time to push the machine harder. I want to make some large decorative panels for my living room wall, a perfect way to see how the machine handles large pieces and relatively long engraving times. I actually designed these panels in Photoshop, then exported it as an SVG file. If you're curious about making SVG files in Photoshop, I covered that in my review of the TwoTrees 450 Pro. I'll link to it in the description. When I first made the design, I actually forgot to add the cut around the outside of the panel, but that's just as well, because I can quickly fix it in Easel. I just used the line tool to draw the outline, and Easel automatically turns it into a cut path. It guarantees a clean single line based on the end mill you've selected. Simple and effective. Before cutting, I added a sacrificial plate to protect the base MDF, then placed my 6mm MDF workpiece on top. I wasn't quite sure how to secure such a large, thin panel, either double-sided tape or clamps. In the end, I went with just clamps. If you have a better method, let me know in the comments. Here's where I made a questionable call. I decided to use a 6mm bit instead of the 3mm straight cut. At the time, it seemed like a good idea, but in reality, it didn't speed up the cut. It only added more stress to both the machine and the material. Still, it gave me a chance to see how the machine performs under heavier load, and it handled it without breaking a sweat. Because of my clamping method, the workpiece did vibrate a bit. Tape probably would have held it steadier, but then I worried I'd need so much tape that I risked damage to the thin strips of MDF when removing the tape. So, not a perfect setup. I got this machine from TwoTrees, and they gave me a discount code for my viewers, so if you're thinking about getting one, you can use the code on the screen and the link in the description. I had set up the cut depth to the thickness of the material and an extra millimeter to be sure. When cutting the outline of the design, I actually had to stop the machine as it cut cleanly through without the final pass. That means I could have saved some time, but just dropping the final pass altogether. I'd end up with a runtime of about 40 minutes then. The results were good overall. There was some tear out on the top surface, but a sharp blade cleaned it up easily. This side will face the wall anyway, and the bottom surface looked clean straight off the machine. I'm really happy with how these turned out, and with the machine itself. Compared to an entry-level CNC, it's a big step up. One thing I didn't like though, the infrared safety beam gave me some trouble. When I clamped larger pieces, the clamps disrupted the beam and shut the machine down before I even got started. It's probably a useful safeguard if you're running jobs all day, but for me it was just frustrating. I'll keep the hardware in place, but remove the wires for a cleaner setup. The real strengths of this machine are clear. The size, the power, and especially the clever design that keeps dust away from sensitive moving parts. That will make a huge difference in longevity and reliability. This thing is built to be a workhorse. I hope you enjoyed my rundown and test of the TwoTrees TTC 6050 CNC machine. Testing this machine gave me an idea for pushing it even further, so make sure to subscribe so you don't miss the next project. Thanks for watching, and I'll see you in the next one.